Hello there, and then welcome to a brand new lesson. This is How Beyond Numbers, where we learn maths in the easy way. In this lesson, we are looking at factorization by grouping. In our previous lesson, we looked at factorization by common factors. There are some cases where you need to group before you can factorize. We'll be looking at the cases that we need to take such initiative, and then we'll also look at the regrouping techniques, after which we'll then solve some examples. Take your pens and then your books so that you solve along as we learn together. So talking of factorization by grouping, it is a technique that is used primarily when an expression has four terms. As you would see, you would apply it also in quadratic trinomials as well. So when the terms or the expressions are four and there is no single factor that is common to all of them, we use the method of factorization by grouping. We do that so that we can break the whole problem into manageable parts. What do I mean by that? Let's say we have an expression such as ax then plus ay plus bx, and then we have by. You realize that there is no one common factor to all these four terms. Hence, we can't use the common factor method, but rather we would have to group. If we are able to group, then we can now consider them in pairs, and then we can use the common factor method. This is the cue you need to know when to use factorization by grouping. So let's look at the regrouping techniques, the techniques that we need to be able to factorize by grouping. These are just the steps you need to follow to be able to factorize by grouping. First of all, you have to group the terms. So if you're able to group the terms, then you factorize each pair. Grouping the term here simply means you split the four terms into two pairs. We would solve more examples and then you would understand what each and every step here means. So if you are given a number of terms, and in this case we are talking of four, you group them into what? Pairs. And then you factorize each pair. Now if you're able to factorize each pair, you realize that each bracket resulting from the factorization of the pairs will be the same. That will lead you to the final factorization. Let's look at some examples that will enhance our understanding. So in this first example, we'll follow the steps to see how best we can do our factorization. We have am plus an plus bm then plus bn. And as you realize, there is no common term for all these terms. Hence, the first step says we should group the terms. So grouping the terms here simply means you write them in pairs. In our first bracket, we are going to put am plus an. And then we put plus. In our second bracket, we have bm plus bn. So with that done, we look at am and then an. Do they have any common term? That is what we mean by you factorize each pair. So do they have any common term? Yes, they do. That is a. So their common factor is a. So that a comes out, and then we now use the common factor method to do this factorization. So a times what gives us am, that is an m. Then a times what gives us an, that is also an n. You do the same to this one as well. Looking at it, their common term is b. So b times what gives us bm, that is m, plus b times what gives us bn, that is also n. Now if you do it well, you realize that the bracket you have here should be the same as the bracket you have here. If that is the case, then you just write one of them out, and then you open a new bracket and put the coefficient of these brackets in that. You see, so the coefficient of this bracket was A. Then we have the coefficient of this other bracket being what? Plus B. This we have here, that is into bracket M plus N. Bracket closed with another bracket A plus B becomes the factorized form of this expression we have over here. Now, if you would want to confirm, you can choose to multiply and you realize that you get the same thing as you have over here. This is how we factorize by grouping. Let's solve some few more examples. In our second question, we have x squared plus 5x plus 2x and then plus 10. And we need to use the method of what? Grouping. So as we said earlier on, we need to what? Pair the terms. Hence, we put x squared plus 5x in one bracket, and then in the other bracket, we put the 2x plus 10. After which we now come and then start our factorization by common factor. What does x squared and then 5x have in common? They both have an x. So we put that x out. Then we ask ourselves, what does x multiply to give us x squared? Or in other words, x squared divided by x gives us what? Gives us an x. Then 5x divided by x also gives us a 5. Better still, you can say x multiplies what to give you 5x. That is up to you, what you are very conversant with. Now, what does 2x plus 10 have in common? They have a factor of 2 in common. So you bring that 2 outside, which is their common factor. Then 2 times what gives us 2x. That is an x. And then 2 also times 5 will then give us the 10. So you put that over here. Once again, you realize that this bracket you have here is the same as what you have here. So we write just one of them, that is x plus 5. After which we write our x plus 2, which are the coefficients of the bracket. And hence it is solved. Very, very simple. Now it is important you take a critical look at the terms when there are negatives in there. For this question, it says 2x squared minus 4x minus 3x plus 6. So 2x squared minus 4x minus 3x plus 6. As you can see, there are 4 terms present over here. 1, 2, 3, then your last one being 4. So to use the method, we say we group them into 2s. Now this is where I would like you to pay close attention to. So we have 2x squared minus 4x. We can put that in one group. But for this group here, you realize that there's a negative in front of the 3x. There are 2 ways you can write it. You can either continue with your plus, and then you put the whole of the negative 3 plus 6 in a bracket. Or you can also choose to, after writing your 2x squared minus 4x, you can choose to bring a minus. That is you factorizing the negative out. Remember, addition is made up of 2 negatives. If there's a negative here, there can also be 2 more negatives here. Factorizing one of them out, we have so negative, then into bracket. This time around, we are not going to write a negative 3x, but then you rather write a 3x minus 6. This is to ensure that if you want to open this bracket to give you back this, it is going to be possible. So that your negative times 3x will give you negative 3x. Then your negative times a positive times a negative 6 would also give you a positive 6. So these 2 are all fine to go with. But for the scope of this lesson, we would continue with the first one we have here. And then you can try this on your own and let me know in the comment section if you were able to get the answer which we seek. So we have our 2x squared minus 4x, that is from this section. What do they have in common? In terms of the coefficient, this is 2 and then this is 4. They both have a 2 in common. But then in terms of the variables, remember our previous rule says we should always take the one with the lower variable. That is x and not x squared. So you take our x then into bracket. 2x times what gives us 2x squared. For the 2 times 1, it gives us 2. So there's no need even writing the 1. But talking of the variable, x times what gives us x squared. So we have our x here. If you are not okay doing it this way, as we have said, you always take the term in question and divide it by a highest common factor. The term we are talking about now is 2x squared, and we are dividing it by 2x. So that this 2 cancels out this 2, and then x divides x squared to give us just 1 of x, which is the same as what we have over here. The next one is a negative 4x, and we are dividing it by our highest common factor, which is 2x. X cancels out x, and 2 divides itself once, and it divides negative 4, negative 2 times. So we have x minus 2, then we close our bracket. Not forgetting our negative here, we bring that. And in this case, we have 3 and then 6. What is their highest common factor? That is definitely 3. Now we start our division all over again. So 3x dividing the 3 we have over here. Now we know this cancels out this 3 and we are left with what? An x. So we come and then write our x. Then we have our negative 6. So negative 6 dividing our 3. So this 3 divides itself once and then it divides negative 6 twice. I don't know if you have seen a pattern, but let me explain this to you. If you are able to work out the first bracket perfectly, that should always give you a clue of what your next bracket is going to be, because we have said they have to be the same. So with that, you can always check yourself. If you are not getting the same, that should tell you are doing something wrong somewhere. You would have to check it again. So with all this, we then have to finalize our factorization. There is x minus 2 here, and there's also x minus 2. So we have our x minus 2 in one bracket. Then in the next bracket, we have our 2x, then minus 3. With that, you are good to go. You have been able to factorize the term you saw up there, all by following the rules. The first rule saying you should group them in pairs. The next one says you should factorize each pair, identify the common bracket, and then you now finalize the factorization. As usual, I'll leave you with some exercises so you try on your own. Test your understanding. So this is what we have here, and you have to try them. 1, 2, 3, 4. They are just 5 questions you can always try on your own to test your understanding. We'll end this lesson here. In our subsequent lesson, we'll look at factorization of quadratic trinomials. This Hub Beyond Numbers where we learn maths the easy way. If this is your first time and you think this channel will be of help to you, you can choose to subscribe if you so do wish, so that anytime I release a video, it's notified as well. See you in our next lesson, and bye for now. Stay safe.